Hello, everyone. My name is Bill Shu.
And I'm Saharsha Navani.
The title of our project is Exploring the Effect of the Solar Eclipse on Wind Speed and Direction in Texas using a Comparative Diurnal Analysis. A solar eclipse is a rare event where the moon blocks the sun, causing quick changes in solar radiation and temperature. This gives us a unique chance to study how the Earth's atmosphere reacts. One specific thing we looked at is the eclipse wind, where these changes affect wind speed and direction. Understanding the eclipse winds could help in studying how rapid changes in solar radiation affects weather patterns and atmospheric dynamics.
Our main research question is, how does the solar eclipse affect wind speed and direction along the path to totality in Texas? We explored this by comparing the eclipse day to the week around it. We use data from the GLOBE program, which promotes Earth science understanding through data collection. Our dataset included 9,118 observations from 15 sites over 9 days, 8 surrounding the day of the solar eclipse and 1 day of the actual solar eclipse, focusing on wind speed and direction.
This map shows where we collected data across Texas. Many of the points are within the path of 100% totality, and most of the others are within 90% totality.
We collected data on wind speed and direction for 8 days around the eclipse. We cleaned, filtered, and converted the data from Central Standard Time to UTC, Universal Time. Using the clean data, we graphed the wind speed and direction of the average diurnal variation against that of the day of the solar eclipse. Then, to analyze the graph and the data, we did t-tests to compare the eclipse day with the weekly average, helping us determine whether conclusions could be made from the differences or if it was a null hypothesis, which would be that there was no correlation, there was no significant difference between the wind speed and direction on the day of the eclipse compared to the average diurnal variation days. Some of the tools we used for this were the GLOBE dataset in the bottom left corner, Matplotlib, NumPy, and Pandas, which are all Python libraries, and Python, the programming language Python, and SciPy to help us do statistical analyses and t-tests on our data.
So these graphs compare the mean wind speed and direction on the eclipse day with the average wind direction and speed over the rest of the week. The top graph shows significant differences in wind speed, ranging from 0.4 to around 1.4 meters per second. The bottom graph shows notable variations in wind direction, where the average wind direction shifts from southeast to east of southeast.
The t-test results for wind speed showed a significant difference between the eclipse day and the weekly average, with a t-statistic of 20.3 and a low p-value. This means that the eclipse had a noticeable impact on wind speed, as the high t-statistic and p-value that is under 0.05 indicates that the results are statistically significant compared to regular weather patterns. The t-test results for wind direction also showed significant differences, with a t-statistics of 11.8 and a p-value of 3.91 to the negative 31st power. This also means that the eclipse had a noticeable impact on wind speed, as the high t-statistic and p-value that's under 0.05 indicates that the results are statistically significant compared to regular weather patterns.
In conclusion, our study found significant changes in the wind speed and direction on the eclipse day compared to the weekly average. The t-test results confirm that the solar eclipse do impact these variables, allowing us to reject the null hypothesis. These findings suggest that the solar eclipse can cause noticeable variations in wind patterns, likely due to the cooling effect of the eclipse, which stabilizes the atmospheric boundary layer. Understanding these changes can help improve weather prediction models and contribute to the broader field of atmospheric science. The observed changes in wind patterns provide valuable insights into how transient events like solar eclipse influence local weather conditions, enhancing our predictive capabilities and knowledge of atmospheric dynamics during such rare events. Here is our abstract. And I really enjoyed the C-SCAN because I learned a lot from the instructors. I gained a lot of experience in data analysis, especially in studying the wind patterns during the solar eclipse. The project and activities helped me understand atmospheric science better, and using advanced tools like ArcGIS and the GLOBE database was really fun. Working with mentors and peers made this experience really enriching.
The SEAS program was an amazing experience. I worked with significant data sets like the Globe Observer database, contributing daily to cloud cover and temperature data. Collaborating with driven interns in the solar eclipse impacts on weather group was inspiring. culminating in a research project that showcased our dedication and excitement. Lastly, we couldn't have done this without our mentors. We want to express our sincere gratitude to Dr. Oluwafemi, Dr. C, and the NASA guest speakers for their invaluable guidance and support throughout this project. We also want to thank the NASA SEAS program and all the instructors for providing this incredible learning opportunity. Thank you.